So we've been talking about ionic bonding, and we know ionic bonding happens between what kind of elements?
Metal and non-metal.
And so what do we know about where metals and nonmetals are on the periodic table?
Well, I think all the metals are on the left side, and all the non-metals are mostly on the right side. Up right.
So they're really far apart. And so if you think about your periodic trends, and think about electronegativity, when things are really far apart, are they going to have similar electronegativity or really different electronegativity?
Well, since they're really far apart in the periodic table, I would say they probably have really different electronegativity.
Right. And so we've got big differences in electronegativity. They've got really different poles on their electrons. And so if they've got really different poles, what happens in ionic bonding to their electrons?
Well, I think the electrons get pulled either all the way towards one or all the way towards the other.
Right. So then in covalent bonding, it's going to be a little bit different. In covalent bonding, what kind of elements do you think we're going to be between?
Covalent, probably nonmetals?
So nonmetals with nonmetals. And since they're a lot closer together, what do you think is going to be true about their electronegativity?
Oh, I see. So since they're all going to be really close in electronegativity, maybe they won't pull the electrons as much?
Right. Since they don't pull as differently, they're going to do more sharing. So if they're sharing completely fairly, they're what we call nonpolar. A good example of a nonpolar covalent bond is going to be if we've got something like O2. Because if I've got an oxygen with an oxygen, how different are their electronegativities going to be?
Oh, they'd be like twins. They'd be the same.
They'd be exactly the same. So they're going to pull exactly the same, which gives us nonpolar. All of our electrons are evenly spread out. And so if we've got a nonpolar covalent compound, they're going to be insoluble in water. We're going to talk about why that is when we talk about polar. They're going to be non-conductors because ionic things, they could conduct if they were molten or in solution because all your ions are moving around. These, they're not going to conduct because all of our electrons are pretty fixed. And then we've already said they're going to share equally. Because they share so equally and their electrons are so nicely spread out, they tend to have really low melting and boiling points. So if you think about O2, what state is O2 in?
O2 is a gas?
O2 is a gas because our O's are going to bond to each other really tightly, but they're not going to interact well with other O2s because there's just all these negatives and they're not going to want to hold together at all.
Oh, so the molecules themselves don't like to mess with the other molecules.
Right.
Gotcha. Okay.
So then if they're somewhere between, so if they're somewhere between someone steals the electrons and so they're sharing completely fairly, they're what we call polar covalent. So they're sharing, but it's not as fair. So think about if you've ever had to share a bed with like a sibling or a friend or something because you're having a sleepover. What happens to the covers most of the time?
Well, it seems like you kind of have like a struggle over the covers, and usually one person gets a good amount of the covers and the other person gets very little of the covers.
Right. And so the electrons are going to do that in polar covalent. The more electronegative is going to hold more of the covers. They're going to be pretty nice and warm. The less electronegative gets kind of cold.
Okay.
So they're going to be positively charged. The more electronegative is going to be negatively charged because it's hogging more of the electrons.
So the weaker one gets less electrons.
Weaker one gets less electrons. And so because of this, they are going to end up being soluble in water because water is polar. Hydrogen and oxygen share, but it's not fair. And so polar things will dissolve with other polar things. They're still going to be really poor conductors because those electrons are still fixed within the molecule. But because you've got those pluses and those minuses, then the plus on one molecule can interact with the minus on another and hold the molecules together a little better. So think about water. Water is always a good example of a polar compound. What state is water in at room temperature?
At room temperature, it's liquid.
It's a liquid because those molecules are being held together more than, say, they were in O2.
Oh, I see. So some part of that water is negative, a little bit more negative, and some part of that water is a little bit more positive.
And it makes the molecules sticky. They're going to stick to each other.
Right, so when that positive and that negative get near each other, they're kind of sticky to each other. Oh, that makes sense.